so welcome to Algebra 2. Today we're going to be going over 1.02 and 1.03. So when I emailed you guys this morning, I let you know that if you're watching via Ustream that you have about a 30-second delay between what I say and it's showing up on your end. So if you're typing in questions, I do have a helper who's going to be writing down your questions, and I will make sure that I go back to those at the end of our session, because sometimes if there's too much of a delay, by the time you ask your question, I have already moved on. So I did email you a set of notes, so if you were able to print those out, you can use those during today's session. Otherwise, just feel free to copy them as we go. Okay, so here we go. Let's get started. So our agenda for today is learning about polynomial long division, synthetic division, and then I did put up your week 2 essential question. So take a quick minute, copy down your essential question. So as you guys are experiencing Ustream from home, I really would like your feedback. So kind of think about the pros and cons. What do you like about it? What would you like to see us change? Because this is new for us today. So you're kind of my guinea pig, because this is my first live session today using Ustream. So just be sure you guys give me really good feedback at the end of today, because I'd love to hear what you think. So our week 2 essential question is, why do we use synthetic division, and what does the answer mean? So sometimes in our answer we're going to have a remainder, sometimes in our answer we're going to have no remainder. So I want to make sure that by the end of the session you know the difference between the two. Okay, and also some of the feedback that I would like is, as far as the writing goes, do you need the font to be bigger? Are there certain colors that don't show up so well? So, just keep all that in mind when you're giving me feedback in the Dropbox for later today. Okay, so we're going to jump into polynomial long division first. So take a quick second and copy down the question. Again, I'm going to be teaching you two methods today, the long division and the synthetic division. Once I show you synthetic division, you're never going to want to go back to long division again. So that's why we do the long division first. So when we write out our problem, the second portion of the problem is called the divisor, and it gets written out in front. So we're going to put the 2y minus 4 out in front. And I do need to get a better stylus before I do this again next week. And then the dividend is going to go inside of my symbol here. Oh yeah, that's not good. I'm going to try and use my finger. So what we're going to ask ourselves is, we say 2y times what number is going to give us 8y squared. So let's start with our number first. So 2 times what number is going to give us 8? So you should be thinking in your head 4. And then y times what number or what variable will give us y squared? So I already have a y, so y times y. Now what we do is, in our head we're going to multiply 2y times 4y and put our answer right here. So 2y times 4y gives us 8y squared. But now I have to multiply the second two together. So I'm going to do the 4y times the negative 4, so I'm going to get negative 16y. Now if you're thinking about regular division, what you guys normally do at this stage is, once you drop down your number, you have to change all of their signs. So we're going to do the same thing here. So this is going to become a negative, and the 16y will become a positive, and we're going to add straight down. So my y squareds are going to go away, and negative 18y plus 16y is going to give me negative 2y. And let's drop down our negative 12. And now we have to do that process again. So we're coming back to the front to our 2y, and we're saying 2y times what number is going to give me negative 2y. So if it's already a 2y times a negative 1. So now when we multiply it all the way through, so my 2y times my negative 1 will give me negative 2y. And my 2y times my negative, oops, I did that wrong. Oh no, I didn't. So 2y times negative 1 is negative 2y, and negative 4 times negative 1 is a positive 4. So So just like we did before, now we go through, we're going to change all of our signs. So that will become a positive, this one will become a negative. And when we add straight down, I'm going to have a remainder of negative 16. So my final answer is 4y minus 1, remainder negative 16. And the remainder, you can either write remainder with the number, or you can put the number divided by the divisor that's out front. So I could say negative 16 over 2y minus 4. So we're going to try this process one more time, and then after I show you synthetic division, you're never going to want to use this way again. Because synthetic division is just a little bit easier. So again, if you're watching via Ustream, you're seeing this about 30 seconds after I've done it live. So if you have a question, just write down the example number. So see how we're on example 1 right now? That way in the chat area, my helper can write down what example it was, what your question was, and I can come back to them at the end. Okay, so example 2, let's do one more long division. So take a second, write that down, set up your paper. So my divisor is going to go out in front, so my x minus 3 is going to go out in front. And then my dividend goes inside of my symbol here. And there's no eraser in this program, so please just bear with me with my terrible writing. Okay, so just like we did last time, we're going to ask ourselves, x times what is going to give me x to the 3rd power? Ooh, I see something even before I go any further. When we're doing long division or synthetic division, you guys have to look at your variables and make sure we're not missing any. So right now I have an x to the 3rd, an x, and a number. I'm missing one right now. So if I try and do my division problem, it's not going to work quite right. So I'm going to cross this off because I have to do something else. So do we see which one's missing? I have an x cubed, an x, and a normal number. One of my exponents is missing. One of my exponents is not up there. So the one that's missing, we have to hold its place with a 0. So I have an x to the 3rd. Do I have an x squared? I don't. So I have to hold its place value by doing a 0x squared. So whenever we're setting up our problems, your exponents have to go in decreasing order. And if you're missing one, you do have to hold its place value with a 0. Now I can start my problem. If you forgot that step, as you go through with your long division, you're going to see what's going to happen in just a minute. There will be a place for you to catch yourself. So let's ask ourselves, x times what will give me x to the 3rd? So x times x squared. X times x squared is x to the 3rd. And then we have to multiply these two. So negative 3 times x squared would give me negative 3x squared. See how if I forgot to add in a 0x squared, there wouldn't be a place for me to line up my x squared term because it can't go with the x. So you always have to have empty place values if you're missing one. So do you guys remember the rule we just did a little bit ago, right? After you write it down there, we're going to change all of their signs. And adding straight down, I would have 3x squared. Let's drop down the rest of my problem. So these take a little bit of work. It's really like traditional long division is, just with variables now. So you're always asking yourself, the front number times what will give you what's left over. So right now there's really like a 1 right there. So what times what will give me a 3? Well, that's going to have to be a 3 for sure. It already has an x, but I need it to be an x squared. So x times what will give me x squared? It needs 1 more x. And now we're going to multiply by both of those terms. So x times 3x would give me 3x squared, and negative 3 times 3x would be negative 9x. We come straight down, change all the signs, so that would become a negative, that would become a positive. So I'm left with 11x minus 5. I'm almost done. So x times what number would give me 11x? X times 11. So that would give me 11x minus 33. Go through and change your signs. So by the time you're done, I would have a remainder of 28. Negative 5 plus 33. So here would be my answer with a remainder of 28. So these are long, they can sort of seem a little bit complicated. That's why we have synthetic division. So the method I'm going to teach you guys next is definitely my favorite. It's probably going to be your favorite too for dividing. So let's move on to example 3, which is synthetic division. So take a quick second and copy that down. Okay, so for synthetic division, you're going to love this method. What we do is we're going to do like an upside down division bar, and I'll show you why in just a minute. And now we get to pick out the coefficients. So coefficients are the numbers that are out in front. So I have a 4, a 10, a negative 26, and a negative 60. And those go right here. 4, 10, negative 26, negative 60. So far, I know this is kind of weird, it's new, it's just a new process for us. Then what we do is we're going to look at, right now this is a factor. Remember when we learned about factors and solutions, factors are always inside the parentheses. Solutions are when you set it equal to 0 and solve. So the solution for this would actually be negative 3. Everybody okay with that? Because negative 3 plus 3 is what you would get to be 0. So when we're using synthetic division, you have to use the solution. So that's the only tricky part. So we're going to put a negative 3 here out in front. So even though it says x plus 3, we have to remember that when we're using synthetic division, we have to use the solution, not the factor. So watch how easy this is. The 4 drops straight down. Now we say negative 3 times 4, and we put our answer right in that empty space. So negative 3 times 4, put our answer right here. So that would be negative 12. Add straight down. So 10 minus 12 would be negative 2. Now we're going to multiply again. So negative 3 times negative 2, let's put our answer in the next empty space. So negative 3 times negative 2 is a 6. I'm going to put that answer in my empty space. Let's add straight down. I would get negative 20. And last one, negative 3 times negative 20 is a positive 60. Add straight down, and I get 0. You are done. This is the same as long division. And you're like, how is that answer the same as long division? I'm going to show you. This is your solution right here. So the way that we write our solution, since we've taken out a factor, and this is kind of a weird idea at first, these are going to be our new coefficients in front of my numbers. But we're going to do one less than what we started with. So if we started with the cubed, this is now going to be my answer, but it's going to go in front of the x squared. So this will be my x squared, my x, and my normal number, or my constant. So let's write my final answers. That would be 4x squared minus 2x minus 20. That's the same answer you would have received had you done the long division. Crazy, huh? It's a little bit faster, a little bit easier. All right, so what I want us to think about as we move through the rest of today, there's two different kinds of problems we're going to get with our synthetic division. What is it going to mean if you have a remainder? This is part of your essential question. And what does it mean if our remainder is 0? So these are kind of two big questions I want you keeping in your mind as we go through the next couple examples. I'm going to talk about them, but this is part of your essential question today. Because notice in this last example, I had a remainder of 0 right there. So what does that mean versus when I end up with a number right there? So you probably don't know the answer to it yet, but you're going to get there as we keep going through today. Okay, so let's try one. There's this thing called the remainder theorem, but I know that when the book gives it to you in mathematical language, it doesn't always make sense. So let's talk through it together. This line should really be right here. It should be like this. Now it looks more like what we just did. Okay, so they're giving us this example. They're saying if here's my equation, and they want to divide by x minus 2. I don't know why. Maybe that, I think that disappeared. They want to divide by x minus 2. You would put a positive 2 over here, and then it's synthetic division like we just did. So drop the 1 down, multiply the 2, add straight down. Multiply 2 times 5, add straight down. Multiply 2 times 6, add straight down. So this time, do you guys see there's not a 0 at the end? So let's talk about what that means. If there's not a 0 at the end, what that means is for this crazy graph at the beginning, 2, 13 would be a coordinate on the graph. That's what that means. So if I were to draw this, I would go over to up 13, however many up it is. That would be a dot on my graph. Kind of cool. So when there's a remainder, what does the remainder mean? It means that it's a point on the graph. That's what it means. So how is that different than if I end up with the 0? Well, let's try one. So in this example, and again, I'm not having you work this one out, I'm just showing it to you. In this example, do you guys see how they ended up with a 0? So let's think about what it means if it's a 0. That's still a point on the graph. So -1, 0 is still a coordinate on the graph. Right there. But what does it mean when it's a dot right on the x-axis? Do you remember? It has like a weird, has a name for it. When it's right on the x-axis, that's called a solution. So if we end up with a 0 remainder, this is a solution of your graph. It's an intercept. So that's the difference between the two. So let's go back. If it's not a 0, what does it mean? It just means it's a point on the graph. That's all. If it is a 0, it's still a point on the graph, but it's a special kind of a point. It's a solution because it's an intercept. So it's a place where it's going to cross the x-axis. So this graph might look something like this, like crazy, something like that. But it would be a spot where it crosses the x-axis. So no matter what, whenever you're doing synthetic division, these two are always a point on the graph. Always. If it's a 0, that just means it's a solution of your graph. So that's the only difference. But it's a big difference because we're going to use that as we move forward. So I'm going to have you try 2 more examples with synthetic division because, again, once I taught that to you, I really doubt you're going to choose long division if you ever have a choice. So I want you to try example 4. So take a quick minute and you work out example 4 using synthetic division. Okay, and if you're watching at home and you do have a question, through KML I had sort of warned you that you have to make an account and log in order to be able to ask a question. So if you want to do that before next session, I can send directions on how to make an account. It's really easy, it takes about 2 minutes, but you have to be logged in as a user in order to be able to ask questions during the live sessions. So once you're done solving this, ask yourself, what does your solution mean? Is your answer a solution or is it just a point on the graph, and how can you tell? Okay, check yourself. Did you put a -3 out in front? Okay, that's kind of the key to synthetic division that we talked about. In this form, this is a factor. For synthetic division, you have to use the solution, so we're always going to be using the opposite. So check your steps. So we drop the 3 down. -3 times 3 is -9. Add straight down. -3 times 2 is -6. Add straight down. And -3 times -8 is a +24. Add straight down. So what you should have found is that you know for sure that that graph is going to have a point at -3, 0. And more importantly, if it's a 0, what does that mean about that point? It is a solution. Excellent, yes. So this one's a solution. Whoa, what happened? That's not nice. That was weird. So apparently I lost all my work, but that was a solution. Can you read me what we ended up having? One of you guys, give me 1 second. Sorry. So this is our first time using this program, so it's a little picky. We're getting used to it still. It's not letting me right now. There we go. Okay, so by the time we divided, what did we end up with?
The complete final answer?
Yeah.
3x squared.
Good, so it would be 3x squared
Plus 2x.
plus 2x.
Minus 8.
My division problem. Here was the factor that we started with in the very beginning, and we learned that -3, 0 was a solution. So let's try one last one, and then we'll call it a day. So it's your choice. Do you want to use synthetic division or long division? But I'm guessing nobody's picking the first one. This one is a little tricky. See if you caught the trick. I'm not going to tell it to you yet. I'm just telling you there's a trick to this one. Anybody think they found the tricky part to the problem? She's nodding. No? So remember we talked about how important the exponents are and not to skip any exponents? I have a fourth, I have a third, I don't have a squared. So when I set up my synthetic division problem, I'm going to put the 2, the 9, but then what's really in front of my x squared? A 0. Yep, because there's really a 0x squared in there. Then I can do my -7 and my 36. Because without that, we have totally skipped the x squared term, and my synthetic division is not going to come out properly. So that is the only tricky part to synthetic division. So let's drop that 2 straight down, and let's go through and multiply. So -4 times 2, -8. Add straight down. -4 times 1, -4. Add straight down. Let's keep going. +16. Give me a 9. And -4 times 9 is -36. So I get a 0. So what did we learn about the -4, 0? It is a solution. Perfect. Yep. So -4, 0 is a solution of this crazy equation. Let me give you a moment to rewrite. What are we left with? So practice rewriting. So take your quotient, rewrite it. So we would end up with 2x to the third. Wow, that's so not very nice. So we would end up with 2x to the third. Let me check somebody else's now that I lost my paper. Plus 1x squared minus 4x plus 9. And all of that would be multiplied by my starting factor, x plus 4. And And what did we learn? We learned that negative 4, 0 was a solution. So anytime you're going to get that 0 remainder, it's automatically a solution, which is really important, especially in Algebra 2, because that means that's a place where it's going to cross your axis. So a little bit later in the semester, we're going to practice factoring this thing completely, meaning we need to change this whole entire thing into little tiny parentheses. So we were able to factor out an x plus 4. Next, we're going to work on factoring the remainder portion of this problem. But that's what's coming a little bit later in the semester. So we want to find all the places where this graph crosses. And we found one already. So that's kind of where we're going this unit. So think about this. If there is a remainder, what does it mean? If the remainder is 0, what does it mean? So use these as sort of like a reflection to wrap up what we've learned today as a little bit of a summary. If you're using the Cornell Notes template, this would be great to put in the bottom of the summary section. And this is also part of your essential question. So these answers will go in the Dropbox for week 2 inside of our classroom. So why do you think we use synthetic division? And what does the answer mean when you have a remainder versus no remainder? So go ahead and add that to the Dropbox for week 2, and you will earn your 10 points of credit. I would love to see you guys in person live. I know that right now nobody has D's and F's, which is fabulous, but I would still love to see you. Typically what we'll do is about 25 to 30 minutes of the live streaming stuff, and then the last 10 minutes would be to work on homework questions in person. So at this point, the recording is finished. I hope you guys have a great day, but I would love to see you in person each week. So thanks. Have a great rest of your week. I know I just have to learn how to stop my recording. Okay. What's the matter?
Start with your